So this one's a little different. We're not going to reflect like we did the last one, so we should expect the staircase, if you will, to go the same way. You know, kind of like this. That part should be the same. The part that might be different, though, is this 3 sitting out front. And what this represents is called a vertical stretch. And what that means is all of our normal, quote unquote, our normal outputs, right, were just the regular integers. So, you know, -2, -1, 0, 1, 2, those kind of whole numbers, but they could have plus or minus signs and zeros on the list. So the difference now is this 3 means not all of those are necessarily going to be used. A vertical stretch usually means this function kind of grows faster. So if it helps, the spaces between the steps are larger, right? You have to take bigger steps as you walk up. So let's kind of explore what this means. So again, let's write x, and this time we've got g of x, 3 times our x. Okay. And so let's plug in our numbers. So let's stick with the normals, -2, -1, 0, 1, and 2. Again, we want to emphasize not just those numbers, but what's happening in between them as well. So here we're looking at 3 times, and we're going to put this -2 into our step function. So you've got 3, and the greatest integer, again, it's just itself, right? Times -2 is a -6. So do you see that that's kind of lengthening out where it normally sits? You've got 3, and then you've got -1 goes in here. And again, it is just the integer itself. So you get -3 out of it. I want to be really clear as I'm writing this. This 3 does not distribute side of this function. So I'm not multiplying these. I'm simplifying this first, and then I'm saying 3 times the result. It's a fine difference, but it is a difference, and I do not want to see that 3 distributed in. That would be like having a 3 and a square root and trying to distribute that in. I know -1's imaginary. I'm not worried about that. It's the concept behind it, right? Be careful with what you're allowed to do with functions and what you're not allowed to do. Those differences are even more important in this class as we prepare for calc in the world beyond. Okay, so you've got 3, you've got your step function of 0. Again, the greatest integer, it is the integer itself. So 3 times 0, which is 0. Okay. You've got 3. We need to find the greatest integer below less than or equal to 1, which is just 1. So 3 times 1 is 3. And 2, I'm going to space that out a little bit. 2. So you've got 3, 2, 3 times 2, which is 6. You'll notice all of our answers are multiples of 3, and it's not by coincidence, right? That's exactly what we multiplied by to get to where we are right now. So as we go to graph this, so in this case, when we go to graph these, again, let's start with just these points. We'll know it's not a linear function. We'll know we need to go back and kind of fill in what's going on. So at -2, I'm going to only do my spacing by 1 this time because I have to go up to 6 and down to 6. I want to make sure I have room. So at -2, our output is down here at -6. And again, I'm just going to leave it as a point for now. -1 and -3, 0, 0, 1, 3, and 2, 6. So again, could be mistaken for a straight line, but we know because we've practiced it is not just a straight line. Make sure you're very, very clear on that. You will not get points if this shows up as a straight line, okay? So what we need to figure out is what's happening in between. Between -1 and -2, we have points like -1.5. What's happening there? Well, if we say 3 and we plug that -1.5 into our step function, again, remember, think of a number line. The greatest integer below that is still a -2. So this is still a -6. So even at 1.5, that's right here, right? We're agreeing with this point. That means that we're going to have this line extending here. And we're going to end with our infamous maybe, open point after it, right? Again, what happens between 0 and -1? Half points are nice to work with, so let's go with -0.5. 3, we've got that -0.5 in the step function, becomes 3 times -1 as well, because the greatest integer below 1/2 is 1/2. So even at 1/2, we're here at this value. So again, they all are going to agree with each other, and then this will be open. And we're going to see this pattern continue. Do you notice the spacing between each group is much larger, right? The spacing between them is actually 3 units. You don't need to necessarily label that, but it did kind of stretch out. That's that vertical stretch in action, right? The spacing between the points increased. So a couple things I just want to point out. You'll notice I did not do extra points right here. You maybe don't have to every single time. I would say you want to establish a pattern. It needs to be really clear that you understand what you're writing down, that you can show to me that you understand. So what I will always recommend is show your work, and I'm going to say show enough work so that it's very clear what's going on. If you're not sure if it's enough, it's probably not. Do another line of work. So plug in 0.5 or 1.5 or another couple of decimals in between, right? So just make sure it's really clear that I can look at this and go, oh yeah, they knew exactly what they were talking about. No problem giving points, right? If there are any areas where I'm kind of like, no, I don't see where this came from, this is unclear, it doesn't make sense, that's where you start to lose points. And I want you to get points, right? I want you to do well in this class, but I do have to make sure that it's clear you understand what you're doing, right? So really keep that in mind. Those are good questions to kind of think about as we enter our second week of classes. All right? See you in the next one.